We want to prove that for all whole number n in the set of the whole numbers, a certain statement Pn is true. What is Pn? For example, if I number my statements, this is the first one, which I call P0. I could have started with P1, but I start with P0, and then this one is P1, P2, P3, P4, P5, okay? For example, I want to prove that for any whole number n, the number 5 to the power of n minus 1 is divisible by 4. This would be 5 to the power of 0 minus 1 is divisible by 4. 5 to the power of 1 minus 1 is divisible by 4. 5 to the power of 2 minus 1 is divisible by 4. 5 to the power of 3, because it's P3, minus 1 is divisible by 4, and so on. So we want to prove an infinity of statements, which means if I want to prove each statement individually, I will have to make an infinity of proofs. So this is going to be very long. There is another way. Let's say, yes, I know it's strange you have dominoes here, but let's say that each statement is a domino like that, and proving that the statement is true is making the domino fall, okay? So I want all these dominoes to fall. I have two choices. Either I make them fall individually, which means I have to prove that every domino falls and it's an infinity of proofs. Or I prove that the first one falls, and I prove that every time a domino falls, then the next one falls, okay? This is the idea of a proof by induction. I will prove that the statement is true for the first one, for P0, and then I will prove that even if it's true for the nth statement, it will be true for the next one, okay? So if this one is true, and I prove that, it is contagious. It makes that if this one is true, then the next one is true. So if this one is true, and I prove it individually, then as the next one is true, this one will be true. As the next one is true, this one will be true. As the next one is true, this one will be true. As the next one is true, this one will be true, and so on. And all the statements will be true. So I only have two things to do. I have to prove that the first one is true, and I have to prove that each time a statement is true, then it makes the next one true, okay? So when I say Pn and Pn plus 1, it can be any couple of statements that are one after the other, right? It can be this one or whatever. If I do that, the first one is true, and every time a domino falls, then the next one falls. Every time a statement is true, then the next one is true. It means that all of them are true. It means that all the dominoes fall. That's the idea of a proof by induction. So I will show you an example of this, and I will write it down. So this is my example of proof by induction. I want to prove that for all n, for any whole number n except 0, 5 to the power of n minus 1 is divisible by 4. So what I call Pn is the statement 4 divides 5 to the power of n minus 1. Then, so I'm writing this like that. 4 divides 5 to the power of n minus 1, which means 5 to the power of n minus 1 is divisible by 4. And I will check the first domino, which is P1. Is it true? What does it mean? P1 means would be 5 to the power of 1 minus 1, which is 4 divides 5 to the power of 1 is 5, minus 1 is 4. And this is true. 4 is divisible by 4. It's obvious, it's true, okay? So now, let's suppose that this is the core of the induction. Pn for a certain n. So let n be a whole number. Suppose that Pn is true. So I say that the domino numbered n falls, and I want to show that, to prove that if this one falls, the next one falls. Which means if this one is true, then the next one is true. And my proof will be finished. I will have proved the statement for the first one and proved that every time a statement is true, then the next one is true. I will have proved that the first domino falls, and then every time that one domino falls, then the next one falls too. I want to prove that Pn plus 1 is true. So I can't write here that Pn plus 1 is true because I didn't prove it yet, but I want to prove that this is divisible by 4. So I will write it like that and try to write it in a way that shows that it is divisible by 4. But I have said that Pn is true. So I'm going to want to use this. I want to use the fact that Pn is true. So if I want to use Pn, I want to use something with a 5 to the power of n in it. Okay? So as Pn is true, I can write this 4 times r plus 1. I will explain this, minus 1. Why is this true? So this is a draft. So here I'm using Pn. Because Pn is 4 divides 5 to the power of n minus 1, which means that 5 to the power of n minus 1 is equal to 4 times something with this something in the integers set. It can be, in fact, it's a whole number, but whatever. So I hope you agree with this. 4 divides this means that this is divisible by 4, which means that this is a multiple of 4, which means that this is 4 times something. If you want, I can write the division. 5 to the power of n minus 1 divided by 4 will be r, and you get a 0 here because it is divisible by 4. Okay. So I have that, which means that 5 to the power of n can be written 4 times r plus 1, it's this one here, for a certain r in the set Z. This is why I can write 5 to the power of n that way. Therefore, I go back to my calculation. 5 to the power of n plus 1 minus 1 is equal to 5 times 4r, I'm expanding this, plus 5 minus 1, which is 5 times 4r plus 4, which means that here I can factor this number here and write it as 4 times 5r plus 1. So I just wrote 5 to the power of n plus 1 minus 1 like as a product of 4 times something. This is an integer. And this is the definition of this being a multiple of 4, which means that 4 divides 5 to the power of n plus 1 minus 1, which means the statement Pn plus 1 is true. So I proved that the statement P1 is true, and that if the statement Pn is true, I used it here, then the statement Pn plus 1 is true. This is my proof by induction. The first domino falls, and then if I make this one fall, then the following one, the next one falls.